Hi everyone. Today we're going to take a look at the second part of data management and manipulation, and we're going to extend into the Pandas library, which if you spend a lot of time in Python you will naturally hear about because it's an extremely powerful library and serves as a sort of intermediary between a number of data sources and high-powered analytics that we would like to do with our data. And the central construct, the central data structure of the Pandas library is the data frame. So that's what we'll be working with throughout our lesson today. We start with a warm-up, which you're welcome to try in the notes. This is an introduction to the date-time library, which ends up being very useful to us when we want to look at series data. So we end up relying on this library to print out sometimes time increments so that we can perhaps examine a variable changing over time. And we'll see it show up from time to time in our lesson and throughout our work next week when we move toward data analysis and data visualization. So we have some objectives, we have some resources, and then let's move into our main part of our lesson. Remember, we worked with NumPy last week and we practiced several methods that have to do with arrays, and we can really think of a data frame as a form of an array. Usually we're looking at a series of rows and columns where the columns represent some variables that we measure and the rows generally represent the individuals or records that we're using. Later on in this lesson, we're going to be using a library or a module that's not part of Anaconda. So you notice we've been running all of our code in Anaconda, which is great because it's easy for us to install libraries that exist within the Anaconda ecosystem, but one of the tools we want to use today is not part of the Anaconda default, so you'll have to install this. And that can take a minute, and if you run into any problems, we may have to search online, Google a little bit to see how we can resolve those issues. Alright, so in addition to installing those libraries, we also have to import. So there's often a two-step process when we want to add something new. We install and then we import. Say, install is to get it on our device and then import is to be able to use it. So I'm importing all of the libraries that I need, and I've already given a bit of an introduction to Pandas. So let's start with a basic example where we create this structure called a data frame. So once we've imported the Pandas library and given it the alias PD, which is the custom, we can use a function called DataFrame. Notice the capital D and capital F. And then we're going to specify a list that contains two lists of items, and we're going to go ahead and create this with column names. So we generally have two arguments in the Pandas data frame function. The first one is the data we would like to use, and the next one is what we would want the columns to be named. So we've created a simple data frame. As usual, we need to know how to manage our data. We need to know how to manipulate our data, and that starts with being able to access the rows and columns. So this part of our lesson practices that. So notice we're defining a new data frame, calling it DF, in the same way we did above, but a slightly larger data frame. And this time, the first entry in each of my lists is going to be the name for a row. So row 1, row 2, row 3. And then my second argument is the column names. And notice I'm giving the first entry of the column names the name row label, and that's going to help us because we'll reference that in the next part. So then we use a function called setIndex, and that function is going to let us decide what the rows are going to be called. So we're just following the methods prescribed in the Pandas library. So a lot of that is just a process of figuring out how we're supposed to do things, how we're supposed to conform to the Pandas library specifications. There's one extra bit of code here that I'm using. I'm printing out the ID, and I'm doing that just to illustrate that we're changing the data frame without making a new copy of the data frame, and that's a concept called mutability, which is kind of important if we're creating larger programs. It can be really useful to rely on the concept of mutability in order to sort of speed things up. We don't want to keep making new copies, and there are some functions that will create a new copy of an object by default, but this does not. So we could say from this data frames are mutable, we've changed something about the data frame, but we haven't created a new instance of the data frame. Okay, so basically what we did was indicate that the R1, R2, R3 were row labels, and that gives us easier access to the contents of each row. So that's going to facilitate our extraction of rows one at a time. Here's how we access column data, and I'm going to print each individual column of the data frame, and it looks like this. So it gives us the row label as the first item, and then the first column here. Oh, so my row label, it's a little bit offset. It's just indicating that the row is included. So that's useful because I usually don't want the contents of a column in isolation. I'd like to know the corresponding row labels. That's useful in data analysis. Okay, so now we can access each column individually. And if we're thinking about real data, which we're going to get into in the end of this lesson, it makes sense for us to practice and think about how we might summarize column data. That's usually what we end up having, right? A column represents some kind of variable. So let's practice accessing a column and finding some summary about it. And when I did this, I thought, oh, I'll just summarize the column, but then I forgot that these are represented as strings. So the way we've input the data is as a string, and that doesn't allow us to do statistical or mathematical operations. So I have to do a conversion. Now, in the Python standard library, we used to just use the float function and wrap that around whatever object we wanted to convert to a float, but we're not able to work with data from a data frame in quite the same way. So we're going to rely on a function in the Pandas library for that. So that's called asTypeFloat. I had to look that up. And I'm going to first start with the object I want to manipulate. So I'm going to choose column C. I'm going to change it to a float next, and then I'm going to find the mean. So here's another example that of something we keep seeing. We keep seeing functions and attributes chained together, and it's important to notice the order, right? Get the column, change it to a float, then find the mean. And the dot is chaining those attributes and operations together. All right, accessing a row by name is a little different in the Pandas library. So we're going to use an attribute called loc for, I believe that stands for location. So if whoops, I forgot to run this. Let's go ahead and run this. There, I got the mean of column C. Okay, that makes sense, right? The mean is 12 right in the middle. Also the median in that case. All right, back to finding a row. Here we go. Let's get one row of data. Data type is object. So this output is specific to Pandas. So that's an instance where I'm accessing a row by its name. I can also access a row by its index. that could be, we practice both tools because there may be circumstances where we want to use one or the other. But notice that if I access the row by its index, I have to use the iLock attribute. So I'm thinking that stands for index location. We can also access multiple columns. Here we go. So maybe I just want 2 parts of the column. Maybe I want to reorder the columns, and it would look like this. Accessing specific cells can be done in 2 ways. Again, we're using the lock attribute from Pandas. Okay, so I think the second method here might be useful if we needed to loop over something and maybe change one of the indices when we're looping over. So again, just important to know that there are 2 possible ways to access the data in a single cell. Also, another useful tool is being able to change a single item in a data frame, and where this can be applied is often if we needed to change, say, empty cells, which are sometimes represented with NA or NaN. If we wanted to do some mathematical operations, we often would have to have those be zeros, or maybe we want them represented in another way. So we can actually change a single cell. So here I'm just changing the item. Where's my data frame? So I'm changing the 2-2 to the words 2-2. So I'm accessing the row 3 and column C, and then setting it equal to something new. And we should notice that it's changing the value but not changing the data frame. And this is done with the attribute. So data frame at this location, change it to a 2-2. And here's another example of that. We're just about done with this first part of our lesson. So slicing, really similar to what we saw with arrays, actually. So here's an example where I slice the first 2 rows. All right, so I'm just taking the first 2 rows, and it looks like I've made a change. I've added an entire column called column X. I might get rid of that for our notes. But for now, we're okay. This is just an example of slicing. So here I have another slicing example where I'm just taking row 1 through row 2 and column B through column C. In the notes, you'll also see some other ways to create data frames. I could have a dictionary that looks like this, and Pandas data frame function can understand this and convert it into a sensible data frame. So notice that the name is the key in the dictionary with a list of possible values. The age is another key in the dictionary with a list of values. And then when I'm creating the data frame, this time I take the data and I specify the index. So this is giving me the names of the rows, rank 1, 2, 3, and 4, and it converts it into a meaningful data frame. We can also do this with a list of dictionaries. So here's my list. I recognize that with the square brackets, and then inside I have dictionaries with the curly brackets. Keys are A and B, and the second one is C. And then the values are 1, 2, and so on. So here we get a data frame where, because the first dictionary did not have a value for the key C, it's represented with not a number, or not available. So here's another example like I was talking about where perhaps we need to change that to a 0. So I'm changing it to a 0. Maybe we need to do something mathematical with that data. All right, so that's the introduction to Pandas and DataFrames. Here we have some exercises for you to try. And then we'll look at Pandas Data Reader, really powerful library for our data extraction.